Welcome back and thank you for joining me. So, yesterday we got the foundations of what are sequences and what are recursive and explicit definitions to a sequence. Now, starting today, we're going to focus on very specific types of sequences. Today and tomorrow, we're dealing with arithmetic sequences. What arithmetic means is between consecutive terms, you're adding a consistent value or subtracting a consistent value. So now you're not going to have all those wacky things happening like we did yesterday. This is always going to be the same, adding the same thing or subtracting the same thing. Now, because of that consistency, it's nice because we have actual formulas, okay? And the really great thing is you get to use a formula sheet on the test, all right? So that's going to be one perk to this is you're going to be given these formulas because by the end of the chapter, we're going to have probably about 9 or 10 formulas to know. And I don't expect you to have those memorized. So you are going to get a sheet with all of these on them. So you'll be given a sheet with the recursive formulas, all right, where you need your initial condition, and then just tell me based on the previous term, what are you doing? Well, in this instance, you're just going to be adding a value or subtracting a value, that common difference. Explicitly, you plug into here. So A of n is that first term plus n minus 1 of those d's, of those common differences. So again, all you have to know is to plug the proper things into those formulas. You will be given the formulas on the test. So to write a recursive or explicit formula, you need the first term, obviously, and both need that common difference. All right, what are you adding and what are you subtracting? And then, of course, you just plug it into the proper format. When you're dealing with explicit formulas, you want to simplify it so it looks like the equation of a line. All right, so every explicit formula should be simplified. Now, let me show you what I mean. So here, we have our first two examples. So, recursive. Okay, so for a recursive definition, you start by labeling that first term. So I start by labeling the A1 is 2. And now let's see what's happening here. What am I adding by to go from term to term? Well, looks like to me, every time I'm adding 3. So to go to my next term, I take my previous term, and all I'm doing is I'm adding 3 to it. So the recursive is super easy. Just label what you're starting with, label that first term, and then just say, well, to find any other term, take the previous term, and all I'm doing, I'm adding 3 to it. Explicit. Explicit says A of n equals A of 1, which is 2, plus n minus 1. Now, for explicit formulas, think of n as your variable, okay? So n is always going to be a part of the explicit formula, not something you plug in, all right? So if I'm finding the explicit formula, n is your variable, and my d in this instance is 3. And then notice my directions say to simplify this so it looks like the equation of a line. Well, what that means is I'm going to distribute that 3 3n minus 3. And now I have like terms. 2 minus 3 is a minus 1. So this is my recursive. This is my explicit. So it's very simple, and especially you're going to be given the formulas. There's nothing to memorize even. So all you have to do is find that common difference and then plug things in to the proper places. So let's talk about our next example. So for a recursive definition, I need that first term. I need my starting point. So I'm starting at 6. And now, what am I doing to go from term to term? Well, in this case, I'm subtracting 5. I'm getting smaller as I go. So because I'm subtracting 5 to go from term to term, that's all I have to put. To get to my next term, I take the previous term, and I'm subtracting 5 from it. Okay, so that is my recursive definition. Give me that starting value, and then tell me I'm taking my previous term, and I'm subtracting 5 from it. Explicitly, the explicit definition. The explicit definition, I just plug everything into the proper place. So A of n equals A1 plus, now remember here, think of n as your variable, okay? It's constructed around whatever n is, which is changing. And then my d, my common difference, is a minus 5. And now the directions say always simplify this, okay? Make it look like the equation of a line. So I distribute the negative 5, so I get minus 5n plus 5, so I get negative 5n plus 11. So as long as you know which formula you're plugging into, this should be a very basic skill, okay? Just putting everything in the right place. So recall to find the nth term, all you have to do is use the explicit formula. Remember, that's the power of having the explicit formula, is it lets you find any term immediately. For recursive, you'd have to build up to that term you're looking for. So now for each of these, I'm going to find a recursive formula, explicit formula, and we're going to find A of 15 together. So recursive. Recursive, remember, I always give my starting point. So I give my 6, and now I need to write what am I doing from my previous term. Well, in this case, between terms, I'm adding 4 each time. So I take my previous term and I simply add 4 to it. So there's my recursive definition. My explicit definition. A of n. Now just follow the formula that's on the previous sheet. A1, which is 6. Think of n as your variable. And then my d, that common difference, is 4. And now I'm just going to simplify this like the equation of a line. I'm going to distribute the 4. So I have 4n minus 4. Combine those. Oh, so an equals 4n plus 2. And then if I want to find A of 15, remember for that, use the explicit formula. Just plug that 15 into the explicit formula. So 4 times 15 is going to be 60 plus 2, so it would equal 62. But again, the biggest thing there is just knowing the explicit formula is what you want to use to calculate any term like that. All right, let's move on to our next example. So again, recursively, you always start with indicating your first term. Okay, so tell me that the first term is 3, and then you're going to tell me what am I doing from the previous term? What am I adding from the previous term to get to the next one? Well, here, it looks like I'm adding 1.5. Okay, so to go from term to term, I'm just adding 1.5 each time. All right, now let's do the explicit formula. So remember, for the explicit formula, we can just follow the setup from the previous page. Take that first term, take that 3, n is my variable, and what am I increasing by? Well, 1.5 each time. All right, so I'm going to simplify this now. So I'm going to distribute that 1.5. So 3 plus 1.5n minus 1.5. Then, of course, those simplify. So I get 1.5n plus 1.5. If I want the 15th term, remember, all you want to do, oh, sorry, that should be 15, is plug 15 into, oh, I'm just going to start fresh. Is plug 15 into the explicit. If you ever want a particular term in the sequence, it's often much, much easier to use the explicit formula. And when you do, in this case, you get 24. So let's take a look at what a word problem would look like. So the number of seats in the first 13 rows in a section of an arena form an arithmetic sequence. Rows 1 and 2 are shown in the diagram. How many seats are in row 13? All right, so we have 14 and 16. I'm getting those from the picture, and then so on and so forth. Now we're being told that it's arithmetic, okay? So because we're being told it's arithmetic, I know I'm adding between terms. So that tells me right away that to go from term to term, I'm just adding 2, okay? Again, that's what arithmetic means, is you're adding between terms. Now, if I'm going to want a future row, a future n, that means explicit is going to be much more useful to me, okay? So I'm going to write the explicit formula, because with the explicit formula, then I'll be able to calculate a future term. So A of n, well, A1, which is 14, plus n minus 1 is my variable, and then I'm adding 2 each time. All right, so let's distribute that 2 to clean this up. Oops. So here's the formula. that's tracking the number of seats. All right? So if I use that formula, I want to know how many seats are in the 13th row. I just plug 13 into there. So 26 plus 12, there's going to be 38 seats in that 13th row. So again, just emphasizing that idea. If you're ever going to need a future term, it's the explicit formula that you go to. That one is typically more useful to us. So lots of good stuff here in discussing these arithmetic sequences in terms of its explicit and recursive definitions. So take a moment for me and please write out that summary, okay? Write something that you noticed or any questions you have, and then come back ready to do your practice work.